Push that rock here with Simpson math. Let's talk about adding algebraic fractions when the denominators share a common factor. In my last little video, we added two fractions, but it was quite easy because the denominators shared no factors. So what we want to do in this video is add a pair of fractions that are algebraic like these, but here this denominator shares a factor with that denominator. How do I know that? Well, look, notice the common factor. If I factor out an x from this binomial, I get x plus 1, which is in common with that factor over there. So just as a reminder, let's go back to grade school and remind ourselves how to add fractions. So here I'm adding a half of a pizza to 5/6 of the same size of a pizza, and we want to know what we're going to get when we put those together, what size or how much of the pizza we would get. It would make sense that we're going to have more than a whole pizza because we have almost a whole here and we add in a whole another half, we're going to have more than a whole pizza. If you try adding straight across, you're going to get only 6/8 of a pizza, which is not more than a whole, so there's something wrong. You don't just add straight across. What do? Oh yeah, you have to get that common denominator. You have to be talking about the same sizes of parts, so same size fractions. So I'm going to divide this fraction into sixths. So if I divide a half into thirds, that's making it into sixths. So here I divided the pizza into 6/6, but a half would be 3/6. So I get 3/6. How do I do that? Well, I multiply top and bottom by 3. 3 times 1 is 3, and 3 times 2 is 6, but I'm multiplying by a form of 1, an arithmetic form of 1. 3 divided by 3 is 1. So if you multiply by 1, you're not changing it. And now I can add to the 5/6. The denominators are just telling us the sizes of the slices we're adding, so we keep the size the same. And this tells us how many of those slices we have. We have 3/6 and we have 5/6. So if we add them together, we get 8/6. And now we can reduce this because the top will factor to 2 times 4 and the bottom will factor to 2 times 3. And so we see we have 4/3 or 1 1/3 of a pizza, like we expected to get a little bit more than a whole pizza. So now, how did I know to get 6 as my denominator? Well, I was secretly kind of factoring this 6 was 2 times 3. So I see it already has a 2, but it needs a 3. This guy has a 2, but needs a 3 in order to be the same as that. We're going to use that same trick when we add the algebraic fraction. So coming over here and looking at the algebraic fractions, notice my very first step was to factor this. So now I can look at these pairs of denominators and figure out what I need in order to build equivalent fractions. I could just multiply this one on top and bottom by x over x. So I have x divided by x, which is 1. But notice now my denominators are going to be the same. This guy's denominator is x times x plus 1. And this fraction's denominator is x times x plus 1. My numerator here stays the same too because I didn't change it. But this guy, I multiplied the x by the x and I get x squared. And now the denominators are the same, so I can put them together. Remember, the denominators are just telling you the size of the slices you're adding up, so you keep the denominator the same. But this is how many of those slices I have. That's how many of those slices I have over there. Put them together, you got to add them. So I get x squared plus 2, and that is the sum of those two algebraic fractions. Math made simple, Simpson math.